The Moon is one celestial body that has been a light in the night sky throughout human existence, and for so many of us, it is as constant and unchangeable as the Sun. But that's simply not the case. The Moon may look like it has been in the same spot in orbit around the Earth, but the truth is, it is actually drifting away from the Earth. But the real question is, why is this happening? How does it affect life on Earth? And will the Moon suddenly drift away from the Earth completely one day? Well, we have all the answers in today's video, where we take a quick look at why the Moon is moving away from the Earth. The Moon's movement away from the Earth is a natural process that has been happening since the Moon was formed around 4.5 billion years ago. The Moon's formation is thought to have been the result of a collision between a Mars-sized protoplanet and the Earth. The debris from this collision eventually coalesced to form the Moon. Scientific simulations of the impact and subsequent creation of the Moon have supported this theory, and also show that the Moon wasn't always at the same distance from the Earth as it is today. Initially, the Moon was much closer to the Earth than it is now. In fact, it was only about 14,000 miles away from the Earth at the time of its formation, much closer than the 250,000 miles distance it is today. Before computer simulations were a thing, famous English astronomer Edmund Halley was the first to suspect the slow drift in the Moon's position by studying ancient eclipses, almost 300 years ago. Scientists were able to conclude after studying laser beams bouncing off reflective panels installed on the Moon by the Apollo missions in the 1970s. The study showed that the Moon was receding from the Earth at a rate of 3.8 centimeters per year, almost about the same speed it takes for our fingernails to grow. So, why is the Moon moving away from the Earth? Well, the Moon is kept in a somewhat stable orbit by the Earth's gravitational pull, but the Moon also exerts its own gravitational force on the Earth. This Earth-Moon force causes the tidal pull of Earth's oceans, causing them to rise and fall. However, the gravitational pull of the Earth also affects the Moon, causing it to bulge slightly at the side facing the Earth. This bulge generates a gravitational force that creates a drag on the Moon's rotation, slowing it down over time. Also, due to the rotation of the Earth, the tidal bulge on Earth actually sits slightly ahead of the Moon. This forward-moving bulge transfers a bit of energy to the Moon, consequently pushing it into a higher orbit away from the Earth. This phenomenon is quite similar to what children experience on a roundabout at a park. The faster the child spins on the roundabout, the stronger the feeling of being slung outwards, and if the child's grip isn't strong enough, it could be flung away, completely out of reach. But then again, the energy received as the Moon recedes into a higher orbit is balanced out by a reduction in the energy of its motion. In essence, an acceleration provided by the Earth's tides and gravity is actually slowing the Moon down. This process is known as tidal locking, and it means that the same side of the Moon is always facing the Earth. However, the Moon's rotation is not perfectly synchronized with its orbit around the Earth, so there is a slight lag. Over time, this slowing of the Moon's rotation causes it to drift away from the Earth. While scientists have calculated the Moon's rate of movement to be 3.8 centimeters a year, it leaves one puzzling question. If we take the Moon's current recession rate of 3.8 centimeters a year and project it back in time, it would mean the Moon must have crashed with the Earth about 1.5 billion years ago. Well, we know no such collision happened, because the first and only collision happened 4.5 billion years ago. So does that mean the current recession rate is wrong? The answer is no. The recession rate isn't wrong, but something else explains the discrepancy in the Moon-Earth distance over the last 4.5 billion years. Scientists have pointed out that factors such as continental drift have had a significant impact on the recession rate of the Moon over the last few billion years. Since tidal friction causes much of the Moon-Earth friction, continental drift would mean some parts facing the Moon have drifted between sea and land. This would have altered the depth and size of oceans, thus affecting the amount of tidal drag. This would have caused fluctuations in the tidal action on the Moon, causing its recession rate to be much slower at certain points in Earth's history, periods spanning tens of millions of years at a time. Experts have also stated that the Milankovitch cycles have had a significant impact on the current steady drift of the Moon away from the Earth. The Milankovitch cycles are concurrent variations in the shape of Earth's axis and its orbit as it impacts the amount of sunlight received on Earth. The amount of sunlight received on Earth affects the variation of climate distribution across the planet, and as such, these cycles determine to large extent the strange weather reversals and changes the Earth has experienced over the last few million years. The Milankovitch cycles cause the periods of greening of the Sahara Desert as well as the size of most major lakes around the planet. These cycles also include the Earth's axial tilt, which affects not just weather patterns but also the length of the day in the northern and southern hemispheres. This axial tilt distorts the Moon's gravitational force on Earth and hence contributes to its steady recession away from our planet. On early Earth, when the Moon was newly formed, days were 5 hours long, but with the Moon's braking effect operating on the Earth for the last 4.5 billion years, days have slowed down to the 24 hours that we are familiar with now, and they will continue to slow down in the future. It's important to note that this process is very slow, and it will take billions of years for the Moon to move significantly farther away from Earth. However, even small changes in the Moon's distance from the Earth can have significant consequences. One consequence of the Moon moving away from the Earth is changing the length of the day. As the Moon's gravity slows down the Earth's rotation, the length of a day gets longer. In fact, the length of a day was only about 22 hours around 600 million years ago, and about 5 hours 4 billion years ago, when the Moon was much closer to the Earth. Over time, the longer days could affect the climate and weather patterns on Earth. For example, the amount of solar energy received by different regions of the Earth varies throughout the day, and changes in the length of a day could alter these patterns. This could result in significant increases in temperature during summer months, as well as a reduction causing drastic freezing during winter in the northern and southern hemisphere. Another major consequence of the Moon moving away from the Earth is changing in the tides. As the Moon moves farther away, its gravitational pull on Earth's oceans decreases, resulting in weaker tides. This could have significant impacts on coastal ecosystems and sea life that rely on tidal patterns for survival. For example, some species of marine life only reproduce during specific tidal phases, and changes in the tides could disrupt these patterns. Migration patterns of certain marine species would be greatly impacted as well, which could lead to reduced reproductions and populations. The Moon's movement away from the Earth would also have an impact on the stability of the Earth's axis. As we've stated, the Moon helps stabilize the Earth's axis of rotation, which is responsible for our planet's seasons. As the Moon moves farther away, it could cause changes in the Earth's tilt, potentially leading to significant changes in our climate and weather patterns. In addition, changes in the Earth's axis could also affect the distribution of sunlight across the Earth's surface, potentially leading to changes in the distribution of rainfall and other weather patterns. In conclusion, the Moon's movement away from the Earth is a slow but significant process that could have far-reaching consequences for our planet. But not to worry. At the current recession rate of the Moon, it would take about 15 billion years before it would completely break out of Earth's orbit and stop moving. This is a very long time in the future, and our Sun would have reached its red giant stage long before then, engulfing our planet as it expands into the habitable zone of the solar system. So, while the Moon's effects might not be too great now, our planet would be engulfed by the Sun long before the Moon completely breaks free from Earth's orbit. Hopefully by then, we would have found a new home on a new planet, where we've probably evolved beyond our current form. That's all we have for today. Do well to join us on the next video.